Hello and welcome back. In the second part of this lesson, 3.5, we're looking at solving systems of equations using substitution. So this is where we're going to isolate one variable and then insert whatever that variable equals into the other equation to find equivalent expressions that allow us to cancel out one of the variables. So this is along the same lines as what we did in elimination, just a little bit different methodology of getting there. So we're going to look at two examples in this video. The first one we're going to look at is example 1. So we have x plus y equals 3x minus 1 is our first equation. And our second equation is going to be x minus y equals 1 minus x. Now, we only have this one y. It's by itself. It's already positive. So I can easily move an x to both sides of this. And then that will leave me, my top equation will be y equals 2x minus 1. This then allows me to take this value for y that we just solved for and insert it into our other equation. So I'm going to take this x minus y equals 1 minus x, and I'm just going to insert this in for y. So that leaves me with x minus, and then it's the quantity 2x minus 1 equals 1 minus x. And it's super important to remember that it's minus that whole quantity, which means we have to distribute that negative to both parts. So this is x minus 2x plus 1, because minus a negative is plus a positive, equals 1 minus x. I can then combine this x minus 2x to just be negative x plus 1 equals 1 minus x. So now I need to get my x's on the same side and my constants on the same side. So if I add x to both sides, plus x, oh, wait a second. When I do that, what happens? Well, I get 1 equals 1. So in the first video, we talked about these special situations where this happens, right? Your variables cancel each other out, and you're simply left with an expression of two constants equaling one another. And we talked about how there were two different possibilities. Either the statement could be true or false. Well, in this case, does 1 equal 1? Yes. When will 1 equal 1? Always, right? This is always going to be a true statement. And because it's a true statement, that means that this is what we call an identity. Oops, we got a T. Okay, so because this is an identity, okay, that means that when it works for one of them, it will work for both of them. So if we solve one of these into standard form, which this one just has this minus x by itself, so we're going to do that one. So we have x minus 1 equals 1 minus x. If we add x to both sides, that gives me 2x minus y equals 1. So that means both of these statements up top are equivalent to this one expression. Okay, so any point that works in this expression, any value of x and y that makes this statement true, will give you a statement that works for both of those, because, as we talked before, it means that these are really the same line, essentially, one on top of the other. So any point that works for either one. So I'm just going to write that out for you. So any point, okay, on this line, or that is a solution to the equation, you can look at it either way, will work, which means that there are infinitely many solutions. So you could go ahead and start putting values in and getting all kinds of different answers, right? You could put in a value for x and solve for y. So this is just looking for a particular one. Sometimes you'll be asked to find a couple, and when you're asked to do that, you simply pick a value for x or y, put it in, and solve for the other one. So for instance, 2 times 0 minus y would have to equal 1. Well, that would be 0, so negative y would have to equal 1, so y would equal negative 1. So that would mean, right, our x value was 0 and our y value is negative 1. So 0, negative 1, right, is just one of those solutions. Okay, but there are infinitely there are an infinite number of solutions because they're infinitely many. So then let's look at another one that isn't going to be a special circumstance. Okay, if I have 3y equals x minus 2y minus 1, and then 3x equals 2x minus y minus 1. Okay, again, I'm looking for which one of these allows me to easily and quickly isolate a variable. Well, I have 3x here, and I have this 2x here. So if I subtract 2x from both sides, this gives me just x equals a negative y minus 1. So I've already isolated for this x. So if I take that and I put it into the top equation where 3y equals x minus 2y minus 1, so I'm just going to take that and insert it in there for x, then that would give me 3y equals a negative y minus 1 minus 2y minus 1. I got a lot of y's in there. So now let's combine like terms over here. So I would have 3y equals, if I have a negative 1y minus 2 more y, that would be a negative 3y. So negative 3y. Then I have negative 1 minus 1 leaves me with minus 2. I now need to get these y's all on the same side. So if I add 3y to both sides, that gives me 6y equals a negative 2. I can then solve for y by dividing both sides by 6. And that gives me y equals a negative 1/3. Just like before, we're only halfway done. We have to finish this, so that means we need to solve for x. So I'm going to take this and put it back into one of the original equations. So if I take my 3x equals 2x minus y, which was minus 1/3, minus 1. So now if I subtract 2x from both sides, that gives me that just simply x equals, well, I have a negative 1/3. Well, a negative, right, would make for a positive 1/3 minus 1. So remember, 1 really is the same, right? Or sorry, negative 1 really equals a negative 3/3. So if I have 1/3 minus 3/3, that means that x equals a negative 2/3. So then my answer would be negative 2/3, comma, negative 1/3. Hopefully you found this helpful in reminding you how to solve systems of equations by using substitution. And the third and final video for this section, we will go over how to use Cramer's rule to solve a system of equations.